Hi, I'm Jim Banko, Vice President of Sales for Pacur, and we have a unique panel up here today. And I want to take the opportunity to thank PMI for giving us the ability to introduce a new product that's been coming about in the medical marketplace for about 2 years now. We've got a unique panel up here. Gary Hawkins. Gary Hawkins represents Eastman Chemical. Eastman's been supplying the rigid medical packaging device market space with resins such as E-Star 6763, Triton, copolyester, as well as other products as well. I'm from Pacur. Pacur takes Eastman's resins and extrudes those into roll stock and sheet products that then get supplied to Plastic Ingenuity, which is a thermoformer that turns those into rigid trays and then sells those to the device companies. What we're going to talk about today is basically a continuation of a journey that started about 3 years ago between Eastman, Pacur, and our thermoforming customers such as Plastic Ingenuity. And that journey has gone from concept to a developed product, a commercialized product, and now one that's actually getting applications in the device industry. So with that said, what I'd like to do is let Gary Hawkins talk about the development process around the actual resins, and then we'll let Jason talk about the applications in the medical field. So with that said, I'll pass this on to Gary.
Thanks, Jim. Thanks for being with us, Jason.
Thanks for inviting me.
So you're right. We started about 3 years ago. Eastman had just been working on our latest development, which at that time was Triton copolyester. And we have a process that we go through called Voice of the Customer interview. And we were asking people in the market, medical device manufacturers, folks like yourselves, what you saw in the market that you needed. And of course, Triton was one of those products that we launched because of that feedback. But we also heard a lot about opaque materials and what people did and didn't like about opaque materials and some of the shortcomings. And one of the largest opaque materials being used in medical packaging is high-impact polystyrene. So we got our heads together and started thinking about what kind of a product we'd like to launch into this industry that would take care of some of those issues that we heard in the field from customers, what they were unhappy with high-impact polystyrene. So we wanted to make a product that was much more stable when it came to sterilization. We wanted to make a product that was much more durable, much cleaner in terms of cutting, but also to be materials of concern free. And also, just in that durability piece, offer things like cushioning that hips cannot offer. So better product protection, more durability in the fact that it protects the sterile barrier, as well as better tear resistance. And on top of all that, it also offers light weighting. It's about 45–50% lighter than hips, and so that allows you to make packages and make them thinner and have less plastic material, so therefore they're more sustainable, which were all things that basically we had heard from the marketplace were needs. So we started making that product and worked very closely with Pacur to understand more about how to extrude it properly, and of course with Jason and his group to understand more about how it thermoformed and what they needed. So we really took not only the medical device manufacturing community's input in, but also input from you and from him and your companies to understand what products were needed, and that's what brought about Eastolite. And so we're thrilled to have launched that back in 2014. And now we're at a point where the product is in the field and gaining some momentum, winning applications, and we'd like to hear a little bit more about that. So do you want to talk about the extrusion piece and then?
Sure. Thanks, Gary. Again, kind of go back a couple years ago, and once we got the resin kind of developed, Pacur needed to be able to extrude that resin, so we went through multiple, trials in order to see whether or not that resin would extrude to the point where we could actually do it efficiently and effectively and repeatable. Because one of the things about the medical industry is they're very, very resistant to change, and there's a lot of risk involved with change. And we needed to make sure that this product was going to be able to be produced repeatably time and time again, following all the ISO standards we needed to. The other thing we wanted to offer the industry was a product that wasn't too much different from what they're used to seeing. And they've been seeing an Eastman product, E-Star 6763, extruded by Pacur, is known in the industry as PETG for a long time. So what we were able to do is take Eastman's product, which was a system, and that system is actually a multi-layer structure where you've got virgin PETG on the top and bottom, and then you've got a foamed version of that in the middle. So here we're not really introducing a new product per se, we're introducing an extension of an existing product. And that's, I think, very comforting for the medical industry. Once we felt comfortable extruding that, it was now the time to take it out and let the customers, the thermoformers in general, try it. So we sent out rolls of material to a number of different thermoformers, one of them being Plastic Ingenuity. They played with the initial versions. Jason and his folks showed parts and stuff to the industry, and then came back to us with more specific needs around gauges and widths and such, and I'll let Jason take it from there.
Thanks, Jim. Yeah, it's been a lot of fun working with the Eastman Group and Pacur Group on the development of this new material. Jim said it exactly right. Customers in this space, medical device, are very hesitant to make changes into new technologies. So the fact that Eastolite was built on the platform of 6763 made a huge difference in customers being comfortable with doing some analysis and review. So our early stage development with this was in the form of sampling various rolls and various densities on existing tools that we had, just to see how it thermoformed. And then from there, we actually worked on the development of some unique tools with some aggressive undercuts and some unique snaps in our tooling, just to see how far we could push the limits of this material and really get a feel for the applications. So that was our early work, trying to sell the benefits that were laid out. And as we ventured into this a little bit further, we discovered there were some certain applications that were a really good fit for this material. There's a big push in the medical device industry to put a tray in a pouch. And for applications that put trays in pouches, typically it's a rigid tray such as PETG or HIPS. And when it goes into a pouch, oftentimes there's a fairly sharp edge on those trays, as anyone that's worked in the industry knows. In some cases with a lightweight product, it's not a big deal. It doesn't cause any issues. But with a heavier product, it does cause some issues and can abrade a pouch. So what happens, the device maker then needs to go to maybe a nylon pouch or a heavier substrate. What we found early on with some trials was, and I have a sample here I can share. This is one of the first commercial samples that we have in the marketplace. If you want to hold that, Gary.
Sure.
This is a catheter tray. It's about 60 inches long, and this specific tray goes into a pouch. Because Eastolite is a foam material, it has a thicker flange from a gauge perspective, and it's fairly soft. So as a result, when this goes into a pouch, we don't see any of that abrasion issues. So that probably, from our perspective, has been probably one of the really great benefits of an application that has found a lot of value to existing customers. So that's, I would say, probably at this point, one of the leading candidates of this material is the tray in a pouch application. There are many more. There are many more advantages to this material, but that's kind of, I would say, from a thermoformer and an MDM perspective, that's definitely pretty high on the list.
Jason, comment. From an OEM's perspective, what did they see in terms of the benefits of that material? Were they able to take any cost out of their system by looking at that type of an application? So,
depending on the material that was previously used, if it was a 6763 clear material. Definitely there's a cost savings because of the yield advantage that you have in the foam material. From a hips perspective, what we have seen is there's a little slight uptick in cost from hips, unless folks are running hips slow. So if you're not cycling hips very slow, you're probably closer to a break even. We actually process hips pretty quickly, so we didn't necessarily recognize that benefit. There are some folks that do still, hips is fairly dusty, so they do have to hand wipe and hand clean trays in some cases. So in those cases where you have extra labor involved, that would definitely help from a cost perspective. So,
can you comment when you're out talking to your customers? What is their view of having less particulate, less angel hair? What's the benefit to them? I mean, you mentioned cleaning, which you guys or some other folks might do when you're thermoforming, but that doesn't necessarily clean everything out of the package.
Sure.
What does that mean to a medical device manufacturer?
Sure. So the one thing I would say is that if you're running hips, you can generate dust from two different areas. One is from the manufacturing when you're actually forming the trays, depending on your process, and we do a pretty good job of not having those issues. But then the other side of it is what you're packing in that tray may dust during vibration. So this Eastolite material trims very well, and it trims very clean. So if it's someone who does have challenges processing that hips material, they're going to find some advantages from a cleanliness there. And then also on the shipping side, it's not going to dust during a vibration as a hips material may. A great example of another application that we have found customers find value in is that in shipping trays. There's a couple reasons for that. Number one, the most low-cost work in process tray out there right now would be typically a hips material or a PET. And this material provides some cushioning effect that a rigid wouldn't. And I know that you've done some studies, Gary, on the impact of that, which you might want to share to the group, but it's significant.
Oh yeah, we have done some cushioning studies where we've used some ASTM type standards that were really developed for much thicker materials and adapted them to thinner sheeting materials that are typically used in thermoforming, and found that Eastolite does provide a lot more cushioning effect than a lot of the competitive, more rigid materials like hips, like PETG, that people would normally use for their packaging. So this does provide that cushioning benefit, probably somewhere upwards of 30% more energy absorption, depending on the thickness. So,
which is fantastic if you have a device that's sensitive to vibration, or if it's a heavy device, it's gonna provide if G forces are an issue, it's gonna provide a much better impact.
Right.
You were able to get steep undercuts out of this material as opposed to what you would normally see out of a high-impact polystyrene. What benefit does that have to the OEM? Is that secure the product in there better? And then what about getting it out of there once it is secured in?
Sure. Sure. We some of our early trials, that was one of our goals, was to try and see how far we could take an undercut that would not normally strip in PETG or in hips. And we were able to successfully get very aggressive on undercuts. From a molding perspective, when you have a very heavy undercut, it's sometimes very difficult to remove it off of the mold. So that was one advantage that we saw in our process, that we could remove aggressive undercuts from the mold much easier than a traditional rigid. You do have to be a little careful that you don't get thinning underneath that undercut if you're too aggressive. But so from a thermoformer's perspective, that was one benefit, that you could get very aggressive. And then from a medical device customer's perspective, with that heavier undercut, we can provide a little better containment on products that you previously couldn't. But what we noticed is because there's still some give in that tray with that foam material, that you can still remove that without excessive pull forces. So it was kind of a happy medium where you get a lot of extra protection and containment, but you don't necessarily have a huge amount of pull force that's as a result.
Now, this product's actually been out in the marketplace for a short period of time.
Yes.
Have any feedback from the operating room nurses on being able to take this out of the pouch and use it effectively?
That's a great question. We have not gotten to that point in the development process where we've gotten feedback in the field, but it'll be fun to see. I think that the feedback from the OEMs and the medical device manufacturers has been very positive. They're very excited about some of the potential applications.
Gary, question for you. Sterilization, obviously that's a critical factor in the medical industry. Can you describe the types of things that your sterilization methods that could be used on this product?
Yeah, great. Yeah, so when we were designing the Eastolite system, we were looking to make sure that we could create a material that would be much more robust, much more stable when it comes to sterilization. You can gamma sterilize it, you can E-beam sterilize it, you can ethylene oxide sterilize it, and it's very stable. And we've done studies, biocompatible studies, to make sure that the material is safe for human contact, safe basically for implantation up to 30 days. But we've also then done aging studies to make sure that after it was sterile that the physical properties didn't change over time, and the material is very stable. You've seen some of the real-time as well as the accelerating aging data.
Correct.
And it's a very stable product. And you can't always say that with all the materials that are available in the market. But this product definitely is very stable when it comes to sterilization. Thank you.
Well, again, this is a continuation of a journey that was started 3 years ago or so. We expect to have more opportunities to have similar discussions as we move forward. I want to thank Jason. I want to thank Gary for participating in the opportunity with PMMI. There is more information about these products on the eastman.com, plasticingenuity.com, as well as Pacur.com. So if you feel free, you're welcome to go to the websites and check it out. We also have a handout that we've prepared specifically for this application and meeting today, and you're welcome to those as well. So again, thank you very much for participating.